10 minutes, and I'll give you a warning when we get to 8 minutes. So it's over to you.
Okay, thank you. So, well, first of all, my name is Nuria Sánchez, and I am a colleague working with María José Jiménez and also José Alberto Díaz, who is going to present also today part of his work. So first of all, I would like to thank you all for giving me the opportunity to present this work at this meeting of the Annex. And what I'm going to present today is research that has been developed in CIEMAT, and that is titled The Application and Validity Assessment of the Dynamic Integration Methods to Obtain the Thermal Transmittance and the Solar Gain Values of walls. So what is the objective of this research is mainly what we want to propose is to use these dynamic integrated methods in order to characterize, in this case, which is the building components, characterizing the thermal transmittance, and specifically in order to expand what is the scope of application of one of the main standards that is used, that is the ISO 9869. So with this objective, what we want to do is to incorporate new indicators of validity for these parameters, characteristic parameters of the building components. And also what we want to do is to include new additional characteristic parameters. For example, we have considered to include the solar transmittance, that is a parameter which is dimensionless. So with this objective of obtaining these more realistic values for these thermal parameters, characteristics, and in order to integrate in, for example, some databases that we can then use when do evaluate or simulate this energy behavior of the buildings. So in order to reduce this gap between the theoretical and the experimental or the real behavior of the building, the real performance. So in order to do that and applying these dynamic integrated methods, we want to obtain, as I said before, is this thermal transmittance and the solar gain values for the walls. So we have based it basically on what is the dynamic energy balance that we have at the indoor surface of these walls. So as you can see in the image, the equation of this system's energy balance is determined by identifying what are the most relevant driving variables that is taking part in it. So as you can see in this case, the most relevant variables that we have identified is the net heat flux, also the temperature difference between the interior and the exterior part of the wall, which is going to drive these heat losses through this sample wall. And also what is the thermal accumulation that is going to be indicated by these changes in the sample temperature. And also we have to consider which is the vertical global solar radiation that is going to induce these solar gains in the wall. So all these factors, as you can see, we have considered in the first equation that is on the slide, which it's this one. So with this energy balance equation, that is, we have integrated that over a period that we consider delta T. So considering this period of integration long in out, we can consider that this thermal accumulation term is going to be negligible compared to the other terms of the equation. So in this case, we are going to obtain this second equation that you can see in this slide. And what we have to do is to approximate this value of the integrals in this period of time using their 10 average values. So the general energy balance equations for the system, for the different system, is obtained as you can see at low in the slide. So we have done this simplification of the analysis through this use of 10 average values in order to estimate the integrals that we necessitate in order to identify this optimal period integration during which the conditions that I have told is going to be met. And afterward all this, the intrinsic parameters of the insulation panels, that is this thermal transmittance and this solar gain, we can obtain through the use of multiple linear regressions and based on the average over a certain integration period. And using this equation derived from the application of the method. So this is an expression that could be considered maybe analogous to the steady state energy balance equation. So to validate, and we want to validate and ensure this reliability of the results as a series of indicators have been considered, and we particularly we want to see the variability in the key parameters that we have studied, that as I have said, is the thermal transmittance and the solar gains. We want to evaluate this variability in these two characteristic parameters. And this variability we are going to represent by the standard deviation that we are going to express as a percentage, and indicating how much the results are going to deviate from the mean value for a given set of data series and over, as I said, a specific integrated period. So regarding this deviation, a lower percentage for us will reflect an improvement and a closer alignment of this model with the real world behavior. And for a great accuracy, any dispersion value exceeding this 10%, we have marked this percentage as a rejection criteria. But however, this percentage needs to be adapted to the specific application or specific needs in order to characterize these parameters. For example, regarding a consideration of a scientific perspective, or maybe from the provider of this panel work, which are the needs that this industrial partner need to, in order to fix these values. So in addition to this deviation in the characteristic parameters, we also are going to include or to add a validation factor that we call the square error. And this is going to be calculated as the average of the coefficients of determination from the linear regression that we have performed for a given period of delta t. And in this case, a higher value of this validation factor indicates that we have a more robust model. And well, based on this criteria, we are going to optimal or to obtain which is the optimal integration period, for example, for each of the samples that we are going to evaluate in a further study. So when we increase the integration period, we usually are going to have
2 minutes left.
Yes,
2 minutes.
to improve a performance. Okay, perfect. Yes, to improve performance indicators of validity. So well, so in this case, what we have been done is to characterize a sample in a study for prefabricated industrialized panels. And we have carried out this campaign maintaining an indoor constant temperature of 40 degrees and varying the outside temperature. So in this case, and using this integration method, what we have seen is through the linear regression, we have determined all these characteristic parameters, that is the thermal transmittance and the solar gain. And in this case, using this validation factor, what we have obtained is that we have obtained a ranging period of 1 to 10 days. And in this case, as you can see in the image, we have evaluated, or we have defined an optimal integration period that falls between the 8 and 10 days, in which this is, I have told before, is going to drop below this 10%. So in addition to this analyze, what we have to do is to determine also this optimal integration period. But in another characteristic, what we have done is, in this case, is to put a panel facing south in order to block or to stop this solar radiation inside in the panels. So in this case, what you can see in the image is that this period, optimal period of integration, is going down, and we have obtained a 1 day for this period of integration that will be optimal in order to obtain these characteristics values, and that we have also verified that in this case, with this using this protective screen, we have obtained also a very similar value of this characteristic parameter for the thermal resistance, that is 1 watt of square meter Kelvin. That is the same that we have obtained in the previous experimental that we have obtained in this case for the 10-day integration period. So we have demonstrated on one hand the reliability of the method that we have used, and on the other hand also, a significant improvement in reducing this optimal integration of periods. So in both cases, and we have provided reliable results and in this case, what we have done is remove one variable of this energy balance equation that also means losing partial of information of the system, because in this case we are not able to obtain this solar gain from these studies.
We need to wrap this up now.
Yes. Okay. Just that we have put some publications paper here, and here is the contact from me and Maria Jose if you have any further questions. And thank you. I'm sorry for the delay.
Very excellent. Thank you very much. Thank you. 29869 presentations, 50, which one more is what I would ask. Right. Fair camp?
Yep.